Okay, ladies and gentlemen, let's do some trig. This is 9.4, and we are working with tangent. So let's get started. So with tangent, we are looking at opposite over adjacent. Okay, so that's the theme of this homework. I like to identify hypotenuse so I don't confuse it with adjacent. So there's the hypotenuse. Let's see what the problem says. Find the tangents of the acute angles. Write each answer as a decimal and as a fraction. Okay. Let's get my calculator ready and let's go. So tangent, there's two acute angles. There's S and there's R. So we'll start with S. Tangent of S equals, so from S, opposite is 28 over adjacent right next to S is 45. And that's why I like to circle the hypotenuse, because technically if I'm thinking of next to S, it's either one of these, but not that one. That's the hypotenuse. So 28 over 45, and then that actually doesn't reduce, but I do want a decimal, so it is 0.6222, 4 decimal places. And then we also want to do the other acute angle, so that's R right there. Now for this one, you're just going to have to change your perspective. Pretend you're standing here at R. Where is opposite? Whoop, it's 45. Over what's adjacent next to, it's that 28, because it can't be 53 because 53 is the hypotenuse. If 28 over 45 doesn't reduce, neither does 45 over 28. But I can round it to 1.607. All right. And then just notice the tangent of one acute angle and the tangent of the other acute angle are just reciprocals of one another. How interesting. I wonder if that happens every time. Let us see. So over here, here's the hypotenuse. And we need to find tangent of G and H. So I'll start with H. If I'm standing at H, the opposite side is 1. And the adjacent side right next to it is 2. That's 0.5. And then tangent of G, the other acute angle, I change my perspective. Now I'm standing at G. Looking across, that's 2. And adjacent is 1. Let's see if that same thing happened. Was the tangent of one acute angle just the reciprocal of the tangent of the other? Yes, it was. Nope. Okay. So now, number 7 to 10, find x. Ooh, we're actually gonna use tangent to find x. So what we do is we look at the angle we know, that's 41 degrees. And then we look at what sides we know in relation to 45. So if I'm standing, 41. If I'm standing at 41, I can see that I've got the opposite. And I've got the adjacent. This guy is hypotenuse. So I have opposite and adjacent. So when I see opposite and adjacent, I think TOA. Tangent, opposite, adjacent. So I will take the tangent of 41. So you always take sine, cosine, tangent of an angle, okay? Only angles go inside trig functions. Tangent of 41 equals opposite, which is 12, over adjacent, which is x. Now when x ends up on the bottom like this, What we can do is cross multiply. That's one option. The other thing that you'll see with a pattern is that this and this will kind of switch places. The tan 41 and the x will switch places, and it'll be x equals 12 over tan 41. You're going to see that that's what happens when we solve this. So you could use that shortcut if you want, but I don't want to confuse anyone, so I'm not going to use a shortcut. I'm just going to cross multiply. So I get x times tan 41 equals 1 times 12, which is 12. And then now I've got to divide tan 41 from both sides. And so now you see the shortcut I was telling you about? That x equals 12 over tangent of 41. Okay, so technically it's degrees on all of these. Okay, so you can see then, when you get the situation where x is in the denominator, if you want to use a shortcut, you just switch the denominator on this side with what's on the other side, and you could skip that middle step. No problem. Okay, and now this is a problem for my calculator, all right? Nobody is going to be able to calculate this on their own. Thank you. So we go 12 divided by tangent. Guys, make sure you know how to use your calculator. And it tells me that it's 13 point, what did they say to round to? The 10th. So 13.8. All right, number 9. So for number 9, they give me this angle of 58. Here's the hypotenuse. So I've got opposite and I've got adjacent. Opposite and adjacent tells me to use TOA. So tangent. So I'm going to go, just so it doesn't get mixed up with the other color, I'm going to write it in blue. Tangent of 58 degrees. So always an angle goes into sine, cosine, and tangent, is opposite, which is 22, over adjacent, which is x. So now, again, you can swap them, or you can do it the real mathematical way, which is to cross multiply. And we'll get, I'll do it on the side because I'm going to run out of space there. I'll get x times tangent of 58. Guys, please don't think of this as tangent times 58. No, this is tangent of 58. Tangent is an operation. Is equal to 22. And then I got to divide tangent of 58. Divide tangent of 58. And I get that x equals 22 divided by tan 58. Ooh. Okay. No, it's okay. That's okay. You don't have to turn down. It's a goal. Okay. 22 divided by tangent of 58. And I get, I didn't show you guys this time, but I typed it in. I made sure to be correct. 13.7. Okay, so that means that x right here on this triangle is 13.7. I do like to look, you guys, and just see, does it make sense? It makes sense. Whatever this angle is going to be less than 58. That's smaller than 22. We're good. Okay, now let's do some error analysis. What did these guys do here? Describe and correct the error. This person said tangent at D, so their perspective is over here at D, is 35 over 37. Well, 35 is opposite. Check. That's good. But is 37 adjacent? I mean, it does look like it's next to it, but unfortunately, they fell into the trap. They didn't circle their hypotenuse first. This is the hypotenuse, And this is the adjacent. Oh, they should have written tangent of D equals opposite, which is 35, over adjacent, which is 12. Okay? And now here we are. They want to use special right triangle to find the tangent of 45. So let's look at our special right triangle. There were two special right triangles, you guys. There was the 45, 45, 90, and there was the 30, 60, 90. Now, if I want the tangent of 45, I'm going to look at the 45, 45, 90. So here it is, 45, 45. And because we're doing ratios, it actually doesn't matter what the sides are. So I like to do the most basic sides that I can. I'll make the legs each 1. So if the legs are 1, to go from a leg to the hypotenuse, I would multiply by rad 2, which means that the hypotenuse would be radical 2. So here is my special right triangle. I'll identify the hypotenuse, and then looking at 45, here is opposite, and here is adjacent. You could have done this 45-degree angle. Standing here, this would be opposite, and that would be adjacent. Doesn't matter, because either way, tangent of 45 degrees is 1 over 1, which is 1. Okay. Lastly, modeling with mathematics. A surveyor is standing 118 feet from the base of the Washington Monument. The surveyor measures an angle of elevation from the ground to the top of the monument to be 78 degrees. Find the height of the monument. Let's see. So here's the monument. Everything's a line in my drawings. Here's the surveyor. They're either lines or dots. Okay. So the surveyor is 118 feet from the base of the monument. We're trying to find the height of the monument, h, so this is our unknown. And then they measure, what they measure is the angle of elevation from the ground to the top of the monument is 78 degrees. So here I am, from 78 right here, this is the hypotenuse. I've got opposite, and I've got adjacent. Opposite and adjacent means tangent. So I'm going to do tangent of 78 degrees, always sine, cosine, tangent of an angle. Tangent of 78 equals opposite, which is h, over adjacent, which is 118. Now, this is an easier situation to solve. No cross multiplication necessary. All we got to do in this case is get rid of the 118 that's on the bottom of h. The way we do that is we multiply both sides by 118. They cancel here, so that I get here 118 times tangent 78 equals h. And then this is a job for the calculator. Tangent, 118 times tangent of 78 east, 555, what are we rounding to? To the nearest foot, so just 555, and then the unit is feet. Okay, that's it. Hope you guys love trig as much as I do. It's my favorite.